So we're going to talk about the different ways that functions can increase and decrease. Differentiable functions can increase in three different ways. So differentiable functions can increase in three different ways. When a function is increasing, the derivative is positive. So for each of these three, the derivative is positive, right? When I focus in on this first one here, I see that I have a derivative here. Maybe that looks like a derivative of like 2. Okay, so slope of the tangent line is like 2 there. But then I have like another derivative here, and it looks like it's less steep. So maybe it's like, instead of 2, it's like a half or 0.5. So what's happening here to my derivatives as x increases? It kind of looks like I'm leveling off. I've got this horizontal tangent line business going on here. My derivatives get closer and closer and closer to 0 is what it looks like. So it starts at 2 and then it's decreasing towards 0. Right? So the rate of increase, which is your derivative, right? So the rate, or the second, it's the derivative of a derivative, right? Is actually slowing down. The derivative here is 2, the derivative here is a half, maybe here it's a third and a fourth. It's slowing down to 0, right? So if it's slowing down, that means that that rate of increase is decreasing. So this has to do with the second derivative. It's the derivative of the derivative. So I take the derivative of the derivative, I get the second derivative. And if the second derivative is decreasing, that means that we're negative. Okay? Now this next one here is a straight line. Now the thing about a straight line is no matter where we pick an x value, my slope is always the same. Sorry about that. So the slope is the same. It's m equal to 2 here. It's m equal to 2 here. No matter what x value you have, it's always the same. So the rate of increase is constant. So it's always going to be a rate of increase of 2. Okay, slopes of lines we could find when we were in high school, right? 8th grade maybe. So the derivative, the change in the derivative, well, if the derivative is always constantly 2, well, what's the derivative of a constant? That's equal to 0, okay? This next one here, we can increase. Now, here we were increasing, and as we increased, it leveled off. Here we increased, and it was increasing at a constant rate. And this last one here, we're increasing. It almost looks like it's exponential, right? The more we increase, the more we increase. Okay, like you think about exponential population, the more people there are, the more the population's going to grow at a higher rate. Okay? So down here, maybe my derivative is like a third, but then over here, my derivative is like 3. Okay, so I'm just, don't read too much into my numbers here. I know that these were kind of reciprocals of each other. I'm just picking numbers that were bigger or smaller according to if we were leveling off or increasing. Okay, so since we're an increasing function, our derivative is positive. But what do we know about the derivatives as x increases? What's happening to the derivatives? Well, it looks like my derivatives, the rate of increase, is actually increasing. Okay? And if that's the case, then the rate of change of the derivative is equal to the second derivative, that's going to be positive. Cool. Now, not only do we need to talk about decreasing, but we also need to talk about, not only do we need to talk about increasing, but we need to talk about the 3 different ways that we're going to decrease for differentiable functions. So here's differentiable functions that are decreasing. Decreasing means that the derivative is negative. Okay? So the derivative is negative for all 3 of those. And if you look at that, negative derivatives going downhill on all those slopes. Now, what do you notice about this here? This looks like a pretty significantly negative slope here. maybe a negative 3. And then here it looks like it's not quite as negative as it was right there. And so I say maybe that's like 0.5, negative 0.5. So we go from negative 3 to negative 0.5, so it's less negative. The slopes are technically increasing, aren't they? It increases from negative 3 to negative 0.5. Now, for this one, it looks like it's kind of leveling off at 0, so my slopes aren't going to become positive. You know, they're leveling off at 0, maybe at the infinity point, right? But they are nevertheless increasing. Okay? So the rate of decrease is slowing, which means that it's increasing. Okay? So it's increasing here. Now, for the derivative of the derivative, the rate of decrease, this is equal to the second derivative, which is positive. Okay? If the second derivative is positive, what do we know? We have a concave up curve. Okay? Just like here, we had a second derivative that was negative, we had a concave down curve. Okay? Over here, we had a second derivative that was positive, and that's a concave up curve. Here, the second derivative was 0, and that meant there was no concavity. So we don't draw any concavity there. Here I have a derivative, maybe of negative 2. And here is the same derivative. Looks like the slope is constant, it's not changing. So the rate of decrease here, so how is the derivative changing? Well, it's not changing, it's constant. Okay, it's always negative 2 no matter what x I plug in. So the derivative of the derivative is the second derivative, and that second derivative equals 0. Now this one here is your exponential downward curve. Unlike here that was like a leveling off downward curve, this one, like the more x increases, the more steep the curve becomes. Maybe here it's like negative a half, and then as I go a little further, that's like negative 2. So my rate of decrease, the slopes here are decreasing. It's getting more and more negative. So the rate of decrease is decreasing, which means that the derivative, the change of the change, which is the second derivative, is negative. Okay? So hopefully this kind of illustrates for you the different ways that we can have differentiable functions that increase and decrease. Okay, so it's kind of summarizing everything here. If your second derivative is negative, you're going to be concave down. If your second derivative is positive, you're going to be concave up. Okay, if here your second derivative is positive, that's concave up. And here your second derivative is negative, you're concave down. Okay?